Welcome to this webinar on alternative methods of skin sensitization testing, which is co-sponsored with PETA International Science Consortium. I'm Philip Lighthouse of Chemical Watch, and I will be moderating the event. Today, introducing speakers today will be Gilly Stoddart, Head of Science from PETA's International Science Consortium. Before I hand over to her, I will run through the format of today's webinar. Today we have two speakers who will each present for about 20 minutes each, and then we will go into a 20-minute Q&A, question and answer session. Delegates can ask questions during the webinar by using the questions box on their screens. Send your questions as early in the webinar as you can, as I can then forward them to the speakers in good time. If your question is not answered during the webinar, please submit it to our forum and we'll address it there. We'll provide the link to the forum at the end of the webinar. If you experience any technical problems during the webinar, you can also use the question box to send a query to my colleague Lorna, who should be able to assist in any technical matters. Delegates should also know that a recording of this webinar, along with all the slides, will be available on the Chemical Watch and the PETA International Science Consortium websites in the next few days. Now let me hand over to Gilly, who will provide some information on this webinar series and introduce you to both of the speakers. Gilly.
Thank you, Philip. I'd like to welcome all the participants to today's webinar on behalf of the PETA International Science Consortium and thank Chemical Watch for their support in hosting these webinars. The goal of this 6-part webinar series is to help registrants plan for the 2018 REACH deadline. Hundreds of thousands of animals have already been used for REACH testing, and millions more are expected to be used in the coming years. However, there are alternative methods that can be used to meet REACH data requirements while minimizing animal testing. For more information on minimizing animal testing for REACH, after the webinar, you can go to our website where you'll find a page dedicated to promoting alternative methods to meet REACH requirements. And also on our website, you'll find recordings of all the past webinars in this series. I'd also like to let you know that our scientists are available to assist registrants in avoiding animal testing, so please feel free to get in touch if you have any questions. I'd like to remind our listeners that we have the 5th webinar in our series, which focuses on acute mammalian toxicity on the 5th of March, and the final webinar in this series, which focuses on alternatives to acute fish toxicity testing, is in early April. We are looking for feedback on this webinar series, so I encourage you to complete the survey after the webinar. Today we will be presenting the 4th webinar in our series, which is focused on non-animal methods for skin sensitization testing. Our speakers are Drs. Susanna Colley and Sylvia Casati. Dr. Colley heads up the BASF Laboratory for Applied Alternative Methods, conducting and developing regulatory accepted and in-house validated alternative methods for local tolerance. Dr. Casati is a scientific officer at the European Union Reference Laboratory for Alternatives to Animal Testing within the European Commission. Dr. Casati has been with ECFAM since 2001. During the webinar, Dr. Colley will first discuss the REACH data requirements for skin sensitization in order to define what is required to replace the animal test. Dr. Casati will provide an overview of the key mechanism of skin sensitization based on the published adverse outcome pathway and describe the in vitro and in chemico methods that can be used to assess skin sensitization. Dr. Casati will briefly introduce the different ways that the in vitro data can be combined in integrated strategies before Dr. Colley focuses on the strategy employed by BASF. She will also present how methods perform for real-life substances as well as specific case studies for read-across approaches as examples of how the methods can be applied for REACH. Dr. Casati will close by reviewing current OECD activities in the field of skin sensitization. With that, I'll pass the controls over to Susanna to start.
Well, thank you very much. Welcome everyone to the webinar, and yeah, we will just jump into the topic with the information requirements under REACH. So skin sensitization is amongst the health endpoints that needs to be assessed for all chemicals that are registered. The mouse local lymph node assay is currently the prescribed method under REACH. However, we have to keep in mind that retrograde animal testing is the last resort under REACH, and alternatives shall be used whenever available. Also, I would like to point out that the European Commission has made a proposal to amend the Annex 7 to that regard. Sorry, is that a question? Okay. So with that, we can move forward to the next slide, please. So sensitization is needed for all substances for the production volume for over 1 ton per year. This slide summarizes an analysis that has been performed at the time of the REACH implementation project, and actually shows that a lot of sensitization data is needed. PETA communicated that this endpoint is an endpoint of concern for the 2018 deadline.
I'm not sure the keys, but
on the next slide.
That's fine. Yeah.
There's one I got off Judy when you were here.
Could you please move forward?
Let's pop it up a little bit.
So on this slide, we have summarized the animal tests that are currently available. So there are 2 regulatory accepted guinea pig tests, so that's the guinea pig maximization and the BULA test, that differ by the use of adjuvant in the maximization test, but not in the BULA test. Both tests assess the induction and elucidation phase of sensitization, but no quantitative information can be gained from those. Besides those tests, there is the mouse-based local lymph node assay, which is OECD 429, and also non-radioactive variants of this assay, so that's OECD 442A and 442B. All 3 mouse-based assays are used for quantitative potency estimation of sensitizers. Please go ahead. Next slide, please. I very briefly will introduce the local lymph node assay here. So as mentioned before, it's a mouse-based assay, and we have the induction phase that is monitored here. So test material is applied to 3 dose groups plus a vehicle control group. Each group consists of 3 animals, and the test material is applied on 3 consecutive days. And after a short rest phase, we have an injection of a radiolabeled thymidine, so a marker that integrates into the proliferating cells. And this is then measured after removal of the lymph nodes by scintillation counting, and this gives an estimate for the proliferation. And on the next slide, we have summarized the difference between the standard local lymph node assay as laid out in OECD 429 and the reduced local lymph node assay, because this is providing an opportunity to reduce the number of animals. But this test is then only to be used to confirm a negative prediction of a skin sensitizer, as only 1 dose group together with a vehicle control group is assessed. And with this introduction on the animal test on sensitization, I would like to hand over to Sylvia to teach us about the adverse outcome pathway and the mechanistic assays to be used.
Okay, thank you, Susanne, for that introduction. So you refer to the main biological mechanisms at the basis of these human health effects. And these mechanisms are known and have been recently organized and documented in the form of an adverse outcome pathway, starting from a molecular initiating event to the adverse effect, represented in this case by allergic contact dermatitis. Within the skin sensitization AOP, there are 4 key events that are really considered important for the adverse effect to occur. The first of these key events is the molecular initiating event, represented by the covalent binding of sensitizers to skin proteins, a process called aptenation. The second key event is represented by responses in keratinocytes. The third key event covers mechanisms of dendritic cell activation and mobilization. The last key event 4, is the proliferation of memory T cell, which is what is measured in the local lymph node assay. Although not considered key events, there are 2 prerequisites for a chemical to be able to interact with the skin proteins, and these are that the chemical penetrates the skin in sufficient quantity and that the chemical acts as a direct acting electrophile. In fact, we know that a proportion of skin sensitizers are not directly reactive, but they need to be transformed into a reactive species, either by cutaneous enzymes or by air oxidation. And these chemicals are referred to as prohaptens and prehaptens. Next slide, please. Non-animal alternative methods for skin sensitization testing are designed to cover the key mechanisms I was talking about before. And if we look at the slides, we can appreciate that the methods currently available provide a good coverage of the adverse outcome pathway. Information on the ability of the chemical to penetrate the skin can be obtained with the in vitro skin absorption method described in the OECD test guideline 428 and from relevant physical chemical properties which are known to influence penetration, such as the molecular weight and the octanol water partition coefficient. In addition, more elaborated toxicokinetics models to simulate skin penetration are becoming available. The identification of prehaptens and prohaptens with in vitro methods still remains a big challenge, since the majority of these methods either lack metabolic capacity or, if they do have, this is only partially representing the skin metabolism in vivo. Nevertheless, there are expert systems available, such as TIMES or other tools like the OECD QSR toolbox that incorporate predictors for abiotic and metabolic transformation and can help to identify pre- and prohaptens. If we consider the molecular initiating event of haptenation, there we have a number of methods designed to quantify chemical reactivity by either measuring the depletion of model peptides or by looking at the formation of adducts following incubation of the test chemicals with model nucleophiles. Some of these assays also provide information on the reaction kinetic. For key event 2, there are various methods available that make use of either keratinocytes-derived cell lines or reconstituted human epidermis. The release of pro-inflammatory mediators such as interleukin-18 or the expressions of genes associated to relevant pathway in keratinocytes are among the most commonly used readouts in these assays. Maturation of dendritic cells covered by key event 3 is typically measured in vitro by quantifying the expression of cell surface markers. There are also methods under development to measure in vivo T-cell proliferation, which is the LLNA readout. Well, given the limited time available today, it would be impossible to provide details on each of these methods. I would suggest that recent reviews on these methods are consulted. And for this reason, today the focus will be on the validated method. It is important to point out that the methods currently available are addressing specific mechanisms within the AOP, and each of them has inherent limitations. For this reason, it is generally accepted that a combination of methods, either in silico, in chemico, or in vitro, is needed for a full replacement of the animal tests, both for hazard identification and risk assessment purposes. Next slide, please. Now, coming back to the validated method, the first method I'm going to describe is the direct peptide reactivity assay. This is an in-chemical method designed to cover the molecular initiating event by measuring reactivity of a chemical towards synthetic peptides containing either lysine or cysteine. The procedure involves that the peptide and the chemical are incubated for 24 hours at room temperature at fixed ratio. And after this incubation period, the concentration of unreactive peptide is measured by HPLC. Peptide reactivity is expressed as the percentage of depleted peptide. Next slide, please. The mean of the percent cysteine and lysine depletion values is used in a prediction model to assign the test chemical to one of 4 reactivity classes. The mean percent depletion value of 6.38, which is statistically derived, is used as a threshold to discriminate between positive and negative prediction. A prediction model also exists, which is based only on cysteine depletion values only, in case of coelution of the test chemical with a lysine peptide. An accurate description of the DPRA procedures is available as a DBR protocol, accessible through the EuroElectron database on alternative methods, at the indicated link. The DPRA is not applicable to the testing of metals, chemicals which are not soluble in the prescribed solvents, and to oxidants, since these promote the dimerization of the cysteine peptide, leading to possible false positive results. It is also not applicable to the testing of complex mixtures of unknown composition due to the defined molar ratio of the chemical and the peptide. In addition, the DPRA does not have metabolic competence system, and therefore prohaptens are not correctly identified. The method was evaluated in a EuroElectron coordinated validation study for transferability and reliability and is now adopted by the OECD. Next slide, please. The second method I'm going to talk about is the keratinosense. Keratinosense addresses the second key event of the adverse outcome pathway by looking at responses in keratinocytes, and specifically at the activation of the antioxidant electrophile response element dependent pathway, a pathway which was shown in several studies to be relevant to the acquisition of skin sensitization. The keratinosense is a luciferase reporter gene assay that makes use of a keratinocyte-derived cell line transfected with a plasmid that contains the luciferase genes under the transcriptional control of an antioxidant response element. The activation of the pathway can be measured by quantifying the induction of the luciferase gene with a lye-producing luciferase substrate. Cells are exposed for 48 hours to 12 concentration of test chemical, and at the end of this period, luciferase fall induction is quantified by luminescence analysis. Cytotoxicity is assessed in parallel. Next slide, please. A prediction is considered positive in the keratinosense if the luciferase activity is 1.5-fold higher and statistically significantly different compared to the solvent control at a concentration with cell viability higher than 70% in at least 2 out of 3 independent repetitions. Also for the keratinosense, a detailed description is available in the form of a DBR protocol. The keratinosense is not applicable to the testing of chemicals which are not soluble in water or DMSO. The method is designed to detect chemicals which react with the cysteine, therefore chemicals with a specific reactivity towards other nucleophiles may give false negative predictions. It has limited metabolic capacity, especially for prohaptens, requiring an activation step by cytochrome P450 enzymes. This is a method which was validated for transferability and reproducibility in an industry-led study and subsequently was peer-reviewed by ECVAM, the Scientific Advisory Committee, and as in the case of the DPRA, the method is accepted by the OECD. Next slide, please. The last method I'm going to talk about is the human cell line activation test. This is a method addressing key event 3 of the adverse outcome pathway by quantifying the expression of cell surface markers of dendritic cell activation. In the case of the H-CLAT, the 2 markers investigated are the CD86 and the CD54, using as experimental model a human monocytic leukemian cell line, the THP1 cells. Cells are exposed for 24 hours to 8 concentration of test chemical, and at the end of the incubation period, the expression of the marker is measured by flow cytometry following self-staining with Fitch-labeled antibodies. Cytotoxicity is also measured in parallel with propidium iodide staining. The relative fluorescence intensity of surface markers compared to solvent controls is the readout in this method. Next slide, please. In the H-CLAT, a prediction is considered positive if the relative fluorescence intensity of either the CD86 or the CD54 or of both markers is equal or higher the defined respective threshold. And this might occur at any dose with variability equal or above 50% in at least 2 out of 3 independent repetitions. I would like again to stress that a detailed description of the procedures and the prediction model is available in the form of a DBR protocol. Chemicals which are not soluble in solvents compatible with the experimental system cannot be reliably tested in the H-CLAT. The THP1 cell line has limited metabolic capacity and therefore some prohaptens might not be correctly detected. There is a risk of false negative results for chemicals with a nocturnal water partition coefficient greater than 3.5. The method was evaluated in a EURAL-ECVAM coordinated validation study for reliability and transferability, and the final version of the recommendation of the EURAL-ECVAM recommendation on the method are in preparation and will be published soon, and the development of the test guideline for the H-CLAT is currently under discussion at the OECD. Next slide, please. So regarding the status of acceptance of these methods, the DBRA and keratinosense test methods went through the approval process at the OECD, and the fresh news we are happy to share is that the 2 test guidelines are now adopted and will be made public available on the OECD website on the 4th of February. So this will be the first 2 test guidelines for skin sensitization testing based on in vitro and in chemical method. I would like to emphasize that given the specific coverage of the AOP and the limitation associated to each individual method, these methods are not proposed as full replacement standalone method, but rather they should be used to support the discrimination between sensitizer and non-sensitizers in combination with other complementary information. In other words, they are proposed in the test guideline to be used within integrated approaches to testing and assessment. The test guideline also foresees that, depending on the regulatory framework, positive results may be used on their own to classify a chemical into hazard category 1 of the GHS, as foreseen, for example, by the provision in Annex 11 of REACH on the use of alternative methods. It was also made very clear in the test guideline that the test method cannot be used on their own for potency subcategorization or potency prediction. Next slide, please. Well, we said that the test methods are proposed to be used within IATA, and we have already heard in the first of this series of webinars about integrated approaches to testing and assessment as structured approaches that integrates and weight all relevant existing data and inform about additional data needs to support a regulatory decision. The type of information that can be used within an IATA for skin sensitization include physical chemical data, in silico predictions, data from in chemical or in vitro method addressing specific key events of the AOP, existing in vivo data, and other types of information. Nevertheless, the final combination of information will very much depend on the chemical under investigation and on the specific regulatory need. Within the IATA, the assessment of the available information is generally performed using weight of evidence approaches or by applying predefined data integration approaches, if these are fit for the specific regulatory purpose, or a combination of both. Next slide, please. In the field of skin sensitization, there are a variety of proposals emerging on how to combine data from alternative non-animal methods for both hazard identification and potency prediction. In this slide, we can see some examples of such approaches that range from simple sequential testing strategies in which the assessment follows a stepwise approach involving interim decision steps to fixed weight of evidence approaches to more complex Bayesian networks. And I will now hand over to Susanne, who will describe in more details one of these data integration approaches, which is being used in her company.
Thank you very much, Sylvia, for this very good overview of the in vitro method. And I will now present the strategy, which is called the 2 out of 3 strategy, or also referred to as the majority vote. And it all started as an BASF internal strategy. So first, we run an in-house validation of several of the in vitro methods using round about 60 substances. The type of substances are listed in the slide, and some of the substances had to be excluded for technical reasons. For example, surfactants which were foam formers could not be used in the flow cytometry, and similar technical reasons. So in the end, we had 54 substances for which both local lymph node assay and human data was available, and we performed the DPRA, the keratonescence, the H-CLAT, the MUST, which is a different assay addressing the same endpoint as the H-CLAT, and the Lucent assay, which is addressing the same endpoint as the keratonescence assay. Next slide, please. So on this slide, the productivity of the assays is summarized. To begin with, I would like to point out that although everybody is referring to local lymph node assay data, the local lymph node assay is far from perfect. So as you can see here, we have an overall accuracy of the local lymph node assay just below 90%. And of course, we have done the statistics for the individual assays, but in the end combined different methods to see whether we could improve the accuracy. And the prediction model combined from the DPRA, Lucent, and modified MUST assay yielded an accuracy of 94% compared to human data. Next slide, please. So other groups also picked up on this method, and actually the group from Andreas Natsch and Chibondo, they ran a similar analysis using the same type of assays, and actually the productivity was very much the same than that obtained for the BASF study, and we now have here 145 substances. Next slide, please. So on this slide, we have again the comparison of the productivities of the different publications. So in the first column, you see the productivity of the 54 substances by Baus et al. Then we have the comparison to the local lymph node assay data. So we see the in vitro strategies actually performing better than when compared to human than to local lymph node assay data. But we did this exercise to then be able to compare the productivity to the Natsch et al. Paper, and we can see that the productivity is rather similar even with the extended data set. And next slide, please. If we now still increase the data set, and this is a publication that has just been accepted, and it's a collaborative work of different people, but now we have more than 200 substances in the data set, and we have the similar comparison here, and it turns out that we have again a very good predictivity of these methods, and in particular the 2 out of 3 approach. Next slide, please. So after having answered the question whether the 2 out of 3 strategy performs for well-defined substances, we have also performed what we call a post-validation exercise for real-life substances. So in this study, we have tested 40 substances that represent the typical testing portfolio of our company. So this is typically not well-defined substances, but rather mixtures and others. So for example, we have isocyanates in the data set, acrylates, agrochemical formulations, surfactants, plant extract, and others. For all these substances, we have in vivo information available with a mix of local lymph node assay and guinea pig data. And on the next slide, please. So in these tables, we have summarized different ways of data interpretation. This is depicted by the different weight of evidences. So we have combined different assays to see how well they perform. But without going through all the data, it turns out that if we exclude polymers or polyethyleneamines, as well as plant extract and agrochemical formulations, all of these three being not within the typical applicability domain of the test, we again obtain similar predictivity to the previously mentioned studies. We have to mention here that the protocols used were slightly modified for all those complex mixtures. A gravimetric approach has been pursued for the assays. And this has to be kept in mind, and this is also why we have then excluded them from this study. Next slide, please. So this slide is summarizing the accuracy of the 2 out of 3 along the adverse outcome pathway. And in the bottom, you can see the numbers of the predictivity, each comparing the local lymph node assay data and the human data. But in general, we have an accuracy of around about 80 to 90%, irrespective of the data set we are analyzing. Next slide, please. So with this, I would like to summarize some of the limitations of the 2 out of 3, which heavily depends on the limitations of the assays used. So substances may be predicted incorrectly if they have a high cytotoxicity in the cell-based assays. We have limitation by solubility in both the aqueous media and the cell cultures, but also sometimes substances are not soluble in the vehicles used in the DPRA. If substances are not stable at high pHs, so that concerns the DPRA as well, this is a problem. Also, as Sylvia has addressed in the previous slides, some substances are pre- or pro-haptens and need metabolic activation or at least oxidation, and if this is not fulfilled to a sufficient degree, those substances are not correctly predicted. Also, and this is going back to the methods used, this 2 out of 3 approach is not currently not used to determine potency of the substances. And as also indicated before, complex mixtures in substances such as polymers are hard to predict. Next slide, please. So here I would like to show you an example how a read-across approach may be used if we use the in vitro data. So here we had a group of glacerates for which we had in vivo data. All of those were in vivo negative, and for additional compound, in vivo data was not available. And we then performed the computational analysis using the OECD toolbox, using the protein binding module, and then also performed the DPRA. And we put all the data together and compared it to the data for the available substances, and we found, or we concluded that the substance in question is also a non-sensitizer. Next slide, please. So to give you an example in the other direction, we also have a read-across example for acrylates. Acrylates are typically sensitizers, as is also depicted by the in vivo data that we have. The mechanism by which these substances act as sensitizers is typically a microacceptor, and this has been predicted for all the substances. And we also had DPRA data for all of those, so all of those were peptide reactive. And then we also performed the cell-based assays for an additional compound. All of the tests are positive, so we here concluded that the compound in question must be sensitized. Next slide, please. Next. So because people always ask questions about the cost of tests, and this is of course also a relevant question for the in vitro tests. I have summarized here the price estimate for the local lymph node assay, which is just below 8,000 euros, and in the full guideline study we need 25 animals, and opposed to that, the 2 out of 3 approach is in the cost range of just below 7,000 euros, so it's just a little bit cheaper. But just to give you a broad estimate where the prices of the two are in the same ballpark. Next slide, please. So in this slide, I actually would like to present to you a strategy that has been proposed by CAL. So this is a 3-class potency prediction model, and in this strategy, in the first step, a positive result in the H-CLAT is classified as a strong or a weak sensitizer based on the minimum reduction threshold that is determined in the H-CLAT. And then in the second step, the DPRA is performed to reliably predict weak and moderate red sensitizers, which the H-CLAT usually fails to detect. So if then both tests are negative, the substance is predicted to be a non-sensitizer, and if they're positive in the DPRA, the substance is predicted to be a weak sensitizer. So this strategy has been validated using 101 substances, and the authors found a good correlation with the corresponding potency classification of the local lymph node assay, and also the strategy showed a low underprediction rate. So with this, I would like to yield the floor back to Sylvia, and would
or in the context of an IATA. This shows that really there are several possibilities for combining information, and this might depend on the chemical under investigation and the specific regulatory needs. In addition, information generated by some of the sources used within these approaches might be covered by the mutual acceptance of data, as in the case of the adopted test methods, but the final assessment, the final outcome is not. There is therefore the risk of inconsistency in the way these approaches are documented, and consequently in the way these are evaluated by the regulatory authorities in the OECD member countries. And because of this risk, the Joint Research Center of the European Commission proposed to the OECD a project on the development of a guidance document on the evaluation and application of IATA for skin sensitization. Next slide, please. This project is ongoing at the OECD and has the overall goal to promote the regulatory consideration of IATA, and this is suggested to be achieved through the development of a set of principles. I think we should move to the next slide. Through the development of a set of principles that an IATA should fulfill to be considered for regulatory purposes, by also providing proper guidance for the reporting of IATA to promote consistent evaluation and application with the OECD member country, and to this end, harmonized templates for reporting both individual information sources and structured approaches to data integration are under development. The guidance document will also include examples of compiled case studies as a guidance for the level of reporting. It is expected that a mature version of the document will be delivered to the OECD by summer next year. This year, sorry. Next slide, please. Next one, please. Okay. In relation still to guidance, a key document that should be consulted before generating data for fulfilling REACH requirements is the endpoint-specific guidance that is available through the ECHA website. The guidance document describes the various non-testing and testing data that can be used for skin sensitization assessment, and also includes a general testing strategy, what we call now IATA, which is basically a stepwise approach to hazard identification and which aims to ensure that the data requirements are fulfilled in the most efficient way by minimizing animal use and costs. This guidance document is currently under revision to take the latest developments into account and is foreseen to be made public available before summer next year. Next slide, please. So we have seen by going through this presentation that an important progress was made in the area of alternative methods for skin sensitization, both in relation to development of individual methods, but also in the development of approaches on how to integrate information from these methods. In order to increase the confidence on these methods and methodologies, the European Partnership for Alternative Approaches to Animal Testing and the Long-Range Research Initiative, together with CEFIC, organized a workshop in 2013 that was hosted by ECHA, and that brought together industries and regulators to discuss about requirements for facilitating acceptability of non-animal integrated testing strategy. A follow-up workshop is foreseen to be held in April this year to continue this discussion by focusing on practical examples of approaches for data integration. These are important initiatives in the area since dialogue between industries and regulators is key to increase confidence in such approaches that ultimately will facilitate their acceptance at regulatory level. Next slide, please. Well, I'm going now to conclude this talk by summarizing the main messages that Susanne and I delivered today. We have seen that an in vivo skin sensitization study is the standard information requirement within REACH, and the local lymph node assay is the first choice assay. Nevertheless, we know that REACH requires that animal tests should be conducted only as a last resort. Before conducting an in vivo study, the specific rules for adaptation and the general rules for adaptation in Annex 11 should be considered. Annex 11 specifies how data from in vitro methods and non-testing methods can be used for that purpose. So far, adopted non-animal test methods for skin sensitization were not available, neither at the OECD level nor at European level. But we have seen that progress was made in this respect, and the first two OECD test guidelines on non-animal testing methods for skin sensitization will become publicly available soon. It is generally accepted that the adopted methods and other available methods will not be sufficient on their own to substitute the animal tests, but that information from different non-animal methods, either in silico, in chemical, or in vitro, will be needed, especially for supporting a negative conclusion. Proposals on how to integrate data from different sources are being made, and most of them are published in the literature, as shown today by Susanne for the 2 of 3 weight of evidence approach. These approaches afford high predictivity for skin sensitization hazard identification. In addition, Susanne provided practical examples of how data from non-animal methods can already be used to support read-across. Assessment of pre- and prohaptens, highly lipophilic and cytotoxic substances represent the main general limitations of the in vivo methods, of the in vitro methods. Also, the current in vitro methods are mainly designed for hazard identification, and potency prediction still remains a challenge. Well-documented integrated approaches might be acceptable to ECHA provided that the conclusions are well substantiated and the approach itself is sufficiently documented, especially in relation to the known limitations and how this might affect the prediction. Proper reporting is also particularly needed for the non-validated assays under REACH. In relation to this, the current OECD activities on the development of guidance document on the reporting evaluation of IATA aim to facilitate their regulatory consideration. Last but not least, it is important to remember that no toxicological test is perfect, including the animal tests, and that an understanding and proper communication of the strengths and limitations of each individual test is important to build confidence in the assay. In the next few slides, there are some relevant references we suggest for those who would like to get more insights in the topic that Suzanne and I presented today. And with this, I conclude our talk and hand over to Philip for the question session.
Thank you very much, Sylvia. I hope everybody is still with us. We've had a few technical problems there, but I hope generally okay. There are quite a few good questions here. So shall we start with some of the more recent questions here? I've got a couple of questions here from Kimberly Norman. Will REACH accept the in vitro data as standalone for sensitization classification or for positives only? Who would like to?
I think I can take this question.
Okay, thank you, Sylvia.
Well, I think that for the moment there are no in vitro methods that can be proposed as standalone full replacement method. And therefore the only possibility is to consider the provisions which are currently in REACH, that to say the positive results can be accepted, but negative results should be considered in the context of a weight of evidence and in the sense that additional evidence is needed and therefore should be complemented with complementary information. And this is the way the current test methods are being proposed also at the OECD level.
Okay, well, there's a supplementary on there. What is the status of the OECD guideline on the H-CLAT test?
I can also take that. The H-CLAT, the H-CLAT test guideline underwent the first commenting round within the WNT, the OECD, and currently the European Commission and Japan are addressing these questions and providing the evidence that was requested on few issues that WNT had on the method. And well, we are having a teleconference with the OECD next week to decide the next steps.
Okay, thank you for that. Question here on the 2 out of 3 approach. To make a 2 of 3 approach, there is no ranking of the tests within the AOP. How would you deal with that problem?
Maybe I can try to answer that question. I'm not sure I'm understanding it fully. Because we have the methods that are used in the 2 out of 3 that address key events of the adverse outcome pathway. So the DPRA is addressing the molecular initiating event, the key event number 1. Then we look at keratinocyte activation using the Lucent assay. And then at the last step in this strategy, we perform the dendritic cell activation assay using the H-CLAT or modified MAPS assay.
Okay. We've got another question here from same questioner Sandra Kiop. Our recent experiences of the test battery is the tests do not fit compared to in vivo data, or results are equivocal due to technical problems, for example, solubility in micelles. Does anybody help with a problem like that?
Yeah, speaking from a technical point of view, This is the reality with a lot of in vitro methods. So the data that we use to evaluate the productivity, reliability, and transferability of the methods is typically not what is referred to real-life substances. And then if people start testing, the world is far less ideal, and you run into problems of solubility, and also there are substances that are just equivocal. But this is also the truth for the animal-based test. So I think there is substances that are not clear sensitizers or non-sensitizers, but borderline substances. But this is true for the in vitro methods as well as the in vivo methods.
Yeah, I would like to add on to what Susanne just said. I mean that in phase of evaluation, of formal evaluation, validation of a test method, it is practically impossible to cover all the chemical work. So the selection of the chemicals is done to maximize chemicals for which we have high quality in vivo data that we use as a benchmark. Therefore, I mean, the practical use of the methods following validation, this is where I mean, we gain insights into the real limitations of the test methods, and this holds true for the in vitro and in vivo method, as Susanne rightly pointed out.
Thank you. An interesting question here from Lindsay Spode. Which, if any, of the in vitro tests can be used with chemical mixtures of unknown composition? Interesting point.
Okay, I think that for the validated methods, well, so far there is limited experience with the testing of mixtures with this method. Technically, both the keratinosense and the H-CLAT are applicable to the testing of multi-constituent substances and mixtures. For these methods, when testing mixtures, consideration should also be given to possible interference of cytotoxic constituents on the final outcome. The DBRA is not applicable to the testing of complex mixtures of unknown composition because of the defined molar ratio of the chemical and the peptide.
Okay. Come down and see what more recent questions we have. Here's a good point. Can the alternative methods be used in other regions of the world, and do the authorities accept the data for classification? Where do we stand on that one?
Yeah, I think that if an alternative methods, it's an adopted test guideline, this falls under the mutual acceptance of data. So in principles, this should be accepted anywhere in the world. If it's not regulatory, well, if it's not at the OECD level, I think that regions might have the possibility to ask to stick to their test method regulations, to the local test method regulations.
Somebody was at the point here. What about coloured chemicals interfering with systems like the H-CLAT? The same person says our experience is that many chemical reactive chemicals like hair dyes are positive in all three tests and different to the LLNA data.
So, colored chemicals are problematic in a lot of in vitro tests, but just from a technical point of view, and well, thinking about the detection systems used in the assays, interference should not be too much of a problem. So, for example, we have H-CLAT UV in the DPRA, and unless we have something absorbed in the same wavelength, the colored nature of the test material should not interfere with the system. The same is true for the cell-based assay. Of course, color controls should then be run to ensure that there is no interference with a specific endpoint. For example, the luminescence measurement in the keratinosense or lucent assay. And we also have the experience that, in particular for the H-CLAT, the staining of the cells might interfere with the scattering of the cells in the flow cytometry. So yes, colored substances may cause a problem, but also you have to keep in mind that hair dyes are typically reactive chemistry, and maybe this is just reality. And we also have to keep in mind that if we expose the cells directly, this is something like a worst-case scenario. So we have the test material is in direct contact with the cell. So this is very much about the hazard, not looking at penetration and all of that, skin metabolism and all that.
Okay. Here's a point about potency. If the in vitro methods do not allow determination of potency, can we conclude that no DNEL, their effect level, can be derived from the in vitro method? This is contrary to the LLNA study, which allowed DNEL derivation from the EC3 value. Does that make sense?
Yes,
Yeah,
this
so
makes sense.
I think, go ahead, Sylvia.
No, go ahead, Susanna. Sorry.
So I say, from the current point of view, DNELs cannot be derived from the in vitro methods, but that's just a matter of fact that as the OECD guidelines will be adopted fairly soon, we are not looking at potency information here. But all the assays, in particular the cell-based assays, different concentrations, so a series of concentrations is being assessed in the assays. And also in the DPRA, we can test different concentrations to eventually be able to derive potency information. But from a regulatory point of view, today we are not in a position to make any quantitative estimation from the validated methods.
Okay. Having a bit of trouble here with my, here we go. Back to the beginning. Could you provide us with information on reliable QSAR tools to predict skin sensitization properties of chemicals? Are these tools validated and regulatorily accepted? This is an early question. Does it still make sense?
Yeah, I think this was one of the topics that was addressed during the first of the series of webinar, and there are a lot of reviews on the use of QSRs for the different endpoints, so I would direct to this type of material for more in-depth understanding.
Okay. Somebody's asking, do these methods work for known metal sensitizers such as nickel and cobalt?
Yeah.
Go ahead, Sylvia.
No, go ahead, Susanna. You have more practical experience than me with this method. So.
Yeah, so clearly just by the mode of mechanism that metals react, or by which metals cause sensitization, those are prone to be false negatives in the DPRA, just because of the matter of fact that the protein binding mechanism is not what's causing the metal sensitization. In the cell-based assays, and of course this is, we could do a detailed review here, which type of metal is reacting in which way in which assay, but generally metals can be tested correctly in the cell-based assays, with of course exceptions as in any test.
Okay, thank you. I'm just wondering, we'll have to finish very soon, I think. Perhaps another question here. What is the global acceptance of the OECD 442C and D? guidelines and other alternatives presented. Currently not even the in vitro irritation testing, if negative, is accepted in China and requires confirmation with in vivo tests. Industry is not looking to run both in vitro and in vivo if not accepted. That is an interesting thought.
Well, I think that we have already discussed about the proposed use of the methods in the test guideline. And yeah, I think that within REACH, again, we said that the use of these guidelines is conceived within a weight of evidence argument. And then in other parts of the world, I think this will very much depend on the regulation within that region. But for sure, I mean, it would be a pity if these test guidelines would trigger animal testing when they're really designed to try to minimize the animal testing.
Okay. Okay. We must be getting very close to the end, I think. Perhaps one last question. Somebody here is saying alternative methods seem to be more time-consuming and cost-intensive than and the benefit seems to be low compared to an OECD test, especially for SMEs. Would you give a comment on that?
Can you repeat for what in particular this is a problem?
Yes, it's somebody presumably from an SME here, a small to medium company, yeah, saying that alternative methods seem to be more time consuming and cost intensive compared to OECD tests.
So according to our experience, the cost, as I have presented, is in the same ballpark than the local lymph node assay, and time also depends on how you perform the assay. So if money is not decisive and you conduct all assays in parallel, I'd say you might end up in the same time range than the local lymph node assay, which is around 3 weeks then. So of course we're not gaining information in terms of, we're not saving any money here, but on the other hand we're looking at the sensitization problem in a far more mechanistic way than in the local lymph node assay. And one thing that people should not forget is that we also, besides REACH, have the cosmetics directive, which does not allow us to conduct animal testing for cosmetic ingredients any longer. So if people are in the position that they are allowed to do animal tests, then it's their choice whether they want to perform the animal test or they prefer the in vitro alternative. But if people, for example, looked at cosmetic ingredients, they do not have a choice and heavily rely on these kind of tests.
Okay. Well, thank you both, Susanna and Sylvia, for that. I think we've come to the end of the webinar. Thank you for good presentations. And I'd like to say, well, a big thank you to both of you. And I have to say we have around about, let me see, well, we have currently 300, but we've had up to about over 500 people here, I think, and a prospect of many more to listen in yet. So thank you very much, and the very best of luck as you go about your work in this field. Thank you both, and to all of the organizers, and goodbye.
Okay, goodbye to everybody.
Thank you, bye-bye.